If you look at the title here of the lesson's called Reciprocal Functions, and the entire unit is called Absolute Value Functions and Reciprocal Functions. So there's only one lesson on the reciprocal. They're not entirely related, but they looks like they put them together. They might have some similarities, but really this reciprocal thing sort of stands on its own. Yeah, so what is a reciprocal? So if your number is 2, what's the reciprocal of 2? 1 over 2, right? So this is the reciprocal. And the reciprocal, all you think to yourself is the numerator and the denominator will switch places. Okay, so the numerator and denominator, they just switch. You get the denominator over the numerator. And then what we're going to do is we're going to apply this to functions and then see what happens. Okay, so you have some original function. The original is f at x, and then we're going to reciprocate it, and you're going to get 1 over f at x. Now, what happens when you put something in the denominator? Obviously something's going to happen, right? You're going to have some key issues. So what do you think is a big one? What are you not allowed to do? Yeah, so that's the big one. So it's like, this is a big question. When is the function equal to 0? Right? That's a natural thing to start with. And do we know how to solve when the function is 0? Yeah, we've been doing that lots. So your x-intercepts, right? So when it's a quadratic, you'd have to like factor it or use quad formula, right? Or you can use technology as well. And then if it's linear, it's pretty straightforward. You just make the y value 0 and solve for x. But we'll see all that happen right away. And then the other interesting thing is, for all numbers, when you reciprocate it, like what's the reciprocal of 3? 1/3. For all numbers, it's different, except for 1. 1, the identity. Can't do 0, because then, so 0 would become 1 over 0, which this is undefined. We can't use this. That's bad, 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 bad. It's an important thing we're going to go over. The other one is, like, what's the reciprocal of 1? It's still 1. And then obviously, if you do that for positives, you can do that for negatives as well. So basically, the identity, the multiplicative identity, 1. So key points, 0 and 1. So we'll get into that. All right, so we're going to do an exploration here. Okay, so you can put this in your calculator if you like. I'm going to stick to the page. So here's f at x, the original. And here's 1 over f at x, okay, the reciprocal. On the left, you have linear. You're used to this. On the right, it might be something brand new to you. And it looks kind of weird, eh? So what can we make some conclusions about, or some observations? Observations. So where is the original negative? Is it the same as the new? So where is the original graph negative? Starting where? Which x value? -3 and to the which direction? For which x values is this function negative? For which x values is this function negative? Anything less than -3, good. And for which x values is this function positive? For all x values greater than -3. Is it similar? Similar. What's up with this one? There's like this spot where it like wants to deflect away. So what is the spot that it's trying to deflect away from? What x value is this? So what do you think? What's happening there? X can't be -3 for the reciprocal. And look on the table of values what it says. Undefined. So what we do there is we draw this vertical graph. That vertical graph is called that vertical line is called a Say it with me. It's a really weird word. Asymptote. Asymptote. It's a weird word. So asymptote is this imaginary line. It's not actually on the graph that the function can't actually attain that value. So it gets really, really, really close to it, but never actually touches it. All right. Okay, let's also look at some other things. So let's look at the linear graph. Starting at -3 for the x values and going to the right. What's happening to this function? Growing, 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 growing forever, right? Okay, and you can see that here. Look at these y values continuing to grow. Relate that to the reciprocal portion of that. Opposite. So as the original grows, the reciprocal decreases. It's really weird. So put your eyes on my whiteboard here. So 1, 2, 3, 4, 5. That sequence is increasing. Reciprocate these: half, third, quarter, fifth. When the numbers are increasing but in the denominator, the actual values are decreasing. So we have an increasing sequence and we have a decreasing sequence here on the whiteboard. That's going to be an important idea that you need to have in your back of your mind right now. Now let's take a look at the negative values. So look at these numbers going this way. Ignore the negatives for now. Are the numbers growing? Yes. And are the reciprocals decreasing? 1, 1/2, 1/3. So same properties, it's just in the opposite direction. While one grows positively, the other shrinks positively. While one grows negatively, the other shrinks negatively. Okay? So we're going to do some of this in more detail shortly, just trying to get an idea of what's happening. So watch with my red pen. As this tends to grow to the right, this tends to shrink to the right. Okay, now watch my green pen. As this tends to decrease to the left, this tends to increase to the left. It's weird, because this is decreasing towards negative infinity, and then here is growing towards 0. So we're going to get more into that. Just want to see the patterns right now. Okay, so let's complete the following statements using the graphs. Okay, so what's the y-intercept of the original? Right here? So what is that, 3? And the y-intercept of 1 over f at x should just be the reciprocal of 3, so it's 1 over 3. So you just take the y value and reciprocate it. The x-intercept of f at x is -3. And then it gives you the equation of the vertical asymptote. And remember, vertical lines have equations x equals. So when x equals -3, you get that vertical line. Let me do that in purple. Okay, and that's this here. So then it says state the coordinates of the 2 points which appear on both the graphs. So which 2 points appear on both the graphs? And let's use the table. Right here. So those are the invariant points. So what does it mean to vary? To change. So what would invary? Not change. So these guys don't change. And why? What's the reciprocal of 1? 1. So that's important there. Okay, lovely. That was mentioned at the beginning of the lesson as well. What about -1? So good. When negative 1 is reciprocated, you also get negative 1. And then you can fill that out at the bottom there. So it says, state the coordinates of the 2 points which appear on both graphs. These points are called the invariant points. How come they didn't give us a spot to put that? So negative 2 comma 1. And what's the other one? What's the value when it's negative? Negative 4 comma negative 1. Okay. So these are the invariant points. They don't change. And then it has the horizontal asymptote.
Mr. Atchison, please call the office.
All right, so the horizontal asymptote. Right now, you've seen the vertical asymptote, right? So now turn your head to the side. See if you can find another vertical asymptote, but with your head to the side. Do you see one? At 0? So there's the horizontal asymptote. And here's the vertical asymptote. The horizontal asymptote can change, yes. And that's more of a 30-1 question, but yes, it can change. Okay, and the horizontal lines, you're used to these ones. You know when we put in horizontal lines on the graphing calculator when we want to do intersections? So as we go, you type y equals some number and it just cuts across. So that's all it is, cutting across at 0. Okay, complete the following. When the function is equal to 0, the graph of y equals 1 over f at x has a vertical asymptote. This is the key right here. That first bullet. That's the one I'm really worried about. And then the second one I'm not too worried about. It's more of a Math 30 or even a Math 31 idea. But it's nice to see it now. It just says, when the function gets really, really big in either direction. So see this? When f at x approaches plus or negative infinity. It just means when f is large, like very large, what's the reciprocal going to be? No, opposite. So what's the most smallest you can be? 0. And usually the horizontal asymptote is 0. So when f is really, really large, the reciprocal approaches really, really small, i.e. 0. Okay, let's try this with a quadratic. Okay, so they're going to give you the original equation, which is quadratic. So here you have this quadratic function, and everybody can see the U-shaped curve. Let me put it in red. So here's this U-shaped curve that everybody's used to, these quadratics. And it's this thing in black that's really weird to us. It's really weird to us. Okay, so first of all, can we just factor this to make it look normal that we're used to? So right away, after it's factored, what can you tell right away? What are the zeros? Okay, so we know that x is plus or minus 2 for the zeros. Can we find those on the chart? Here's one, and here's the other. And right away, what do you notice? Undefined, because you can't do 1 divided by 0. So then this gives us our vertical asymptotes. And that's the thing that you're going to have to really try to remember. Where do the vertical asymptotes come from? So then you would take your straight edge tool, whether it's bank card or whatever, or a ruler or whatever, and you're going to want to draw those in. I'm just going to use purple or something. So right at wish it was dashed. Okay, so there is one of them. Copy and paste. Here's the other one. So you guys ever hear like the MC Hammer song, "Can't Touch This"? Yeah, so this is like an asymptote. Like you can't touch it. My graph is getting sort of pixelated, but the black graph should not come anywhere near that purple line. I mean, it gets really, really close to it, but it doesn't touch it. You never touch it. MC Hammer, right? Can't touch this. That's how you want to remember that. So vertical asymptotes, MC Hammer. Can't touch it, okay? So what's the next thing that we should look at? If we are interested where the original function was 0 and then got the VAs, now we want to work towards what's the other key point? Not 0, but 1. So what happens when the function is 1? It's the same. So where's the function 1? Here's 1. So it's almost like draw another horizontal line. So right there. What's intersecting that line? The black and the red. Do you see them? See where the black and the red meet? Notice how that point didn't change? Okay, let's draw that line again at -1. You see another spot where they... Okay, I'm going to color it with green. This spot here, this spot here, this spot here, and this spot here. Those green are called invariant because they're in the same spot on both graphs. -3, 5. 1, 2, 3. 1, 2, 3, 4. Like up here? Oh, this is the original red graph. And then the black is the reciprocal. So only at the green dots do you have invariant. Because it's the black graph and the red graph where they meet. Okay. What's another interesting point is just to see what's happening. What is the value of the vertex here? 0, -4. So what's the reciprocal of -4? A quarter, right? So where is 0, a quarter? Right here. Do you see it? 0, quarter. Okay, so this is confusing me at first. Like all this is doing is pointing to the original. So the red line is the original, and then this right here, it's just pointing to the reciprocal, which is the black line. So this is the black. So maybe I'll put a red around this one. Okay, now this is where it gets dicey. And I wish I had a pointer. Do I got a pointer? It's just going to move. I'll use my mouse. Okay. Okay, so watch my mouse. So starting at this invariant point, and it doesn't really matter where you start. You can start it anywhere. But how about we start at 0? This is where the red graph is 0. Everybody with me? We're at negative. Let's start with -2. X value, excuse me, -2. So put my cursor here. So Let's follow the red graph. What's happening to the red graph as x gets really small, like smaller? This red graph is continuing to grow forever, right? So what would you expect to the reciprocal graph? If this one's growing this way, what's the reciprocal going to be doing? Shrinking. And you get really, really, really close to 0, but you never touch it. So as this gets really, 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 really big, the flipped graph is getting really, 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 really small. And then there's some symmetry on the other side. So now this is at x positive 2. So as we go to the right for x. So now imagine you're starting the experiment at time 2 seconds, and you're just going to go press go. So all the x values are going this way. So what's the result? The red graph shoots up like this. Everybody see that? The red graph continues to grow, while the reciprocal graph tends to shrink towards 0. Now this is where it gets real crazy. So what's the reciprocal of -4? We already know it's quarter. So you started 4, the reciprocal is a quarter. That's smaller, right? Okay. So you would expect these values to be smaller, right? Smaller. These are all the reflected. So like if I pick a point right here, it's got the reciprocal here. Okay? Now watch what happens. What happens when you cross the invariant point? It's hard to see, but as you cross the invariant point, now you're taking the reciprocal of numbers that are less than 1. So what happens to the reciprocal? It flips, and now it's bigger. So this is where it gets real hard. So watch my finger. It's like shadows. And then those people can't see. So as this goes this way, this one's going this way. Then they meet at the invariant point, and then it switches. So the red graph, when it crosses this black line, it's now less than 1. So what happens when you reciprocate like a half? What happens when you reciprocate half? You get 2, so it gets bigger. So when you start to reciprocate in here, it actually gets bigger. It's really weird. Now watch what happens as you get really, 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 really close to 0 on the red graph. The black graph is really, really, really close to infinity. So it's really, really bizarre. And let me show you with the calculator. Let me show with the calculator. Okay. Is 10 very big? It's big? Is 100 big? Is 1,000 bigger? Even bigger, right? What are we getting close to? So large, right? What happens when you reciprocate something huge? It becomes super small. Okay? So if this is some random function, we wanted to reciprocate it, we'd have to know where it is 0. At 0, we can do this. Okay? Because that's at that spot, the reciprocal is going to be weird, right? So we put that vertical line. And then I also want to know where it's going to be the same. So here and here. Because I know when you reciprocate 1, it's not going to change. Now check this out. In this little interval here, when the y values become really, really, really close to 0, what should the reciprocal do? has that curved nature to it. Now, when these y values get really, really, really big, the reciprocal should do the opposite. Oh, that was dumb. Come on, smartboard. It should do this. And there's the first part of that graph. The green is the reciprocal. Now check this out. This is 0. So when I reciprocate numbers between 0 and 1, I should expect what? In here. Let me do it again. Start at -1. What's the reciprocal of -1? Doesn't change. What's the reciprocal of half? 2. So it's going to be somewhere out here. What's the reciprocal of a quarter? Can I get a red pen in there, please? You said a fourth, so it's out here maybe. What's the reciprocal of an eighth? That would be 8, right? And I could do this infinitely. What's the reciprocal of a 16th? Well, 16. So what's happening? As you get really, really small towards 0, the reciprocal gets really, really big towards -infinity. Now watch this. Starting at 1, what's the reciprocal of -1? -1, right? So what's the reciprocal of -2? Reciprocal of -2? Half, right? What's the reciprocal of -4? And it's in the same x position, it'll be a quarter. So see how it's getting smaller and smaller? So then that's that. And you never touch 0. You get close to it, but you never touch it. You see that symmetry? Question? Oh, the horizontal asymptote? Yeah, it's going to usually be 0 for you guys. And the reason is, like, as you follow this graph, you get really, 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 really big. The reciprocal of that is really, really, really small, which is 0. In other words, 0. Yeah. So as this becomes, it's like if this y value was like 1,000,000, then the reciprocal would be right here, 1,000,000th, which is basically nothing. Yeah, so 0. Yeah. All right. Okay, let's just fill these in. So if you want to study, because we've talked about all of them, it's just really weird. Okay, so y-intercept, -4, the reciprocal would be -1/4. We talked about that one. The x-intercepts are -2 and 2. We talked about that, and their corresponding vertical asymptotes. We talked about those. And then the horizontal asymptote is going to be this. I'm assuming that's always going to be true for math 20-1. Just assume that this is always going to be the case. There will be times when it won't be. But we're not going to worry about that right now. Invariant points. That's what they want on this one. So what were the invariant points here? We had to go and find them, didn't we? What did we have? Didn't tell us in there. Okay, so it says to find the invariant points, so you'd want to set the function equal to 0, or pardon me, to 1, and set the function equal to -1 and then solve for it. What's the function? X squared minus 4, right? And then you go ahead and solve these. So you would have to bring the 4 over and add it, and then you'd have like plus or minus √5. So x squared equals 5, x equals plus or minus root 5. This one would be x squared equals a plus 4, get 3, x equals plus or minus root 3. Okay, so you get 2 from there, 2 from here, and you would have those up here somewhere on the graph. Okay, complete the following. When the function is 0, you got the vertical. As the function approaches infinity in both directions, it gets closer to a horizontal asymptote of 0. Okay, so kind of just going through the motions for the next couple minutes, and then I'll help you with the questions as they come. Okay, just for studying purposes, we've already done all this, so let me just write it in. Okay, so this is some stuff we've talked about. We haven't really formalized it. So when the function is positive, the reciprocal is also positive. That's how I started it off the lesson with. If the function is negative, then so is the reciprocal. So that's key. This is the invariant stuff. So when the function is 1, so is the reciprocal. And when the function is negative 1, so is the reciprocal. And then this is for all understanding. Double star here. When the function increases over the interval, and the interval is like whatever section you're looking at, then this will do the opposite. The reciprocal will decrease. And if it decreases, the reciprocal will increase. And 4, we've talked about this on the last page. When the function approaches 0, so let me translate this math speak to you. When the function approaches 0, so as the function gets small, the reciprocal gets big. And the graph approaches when the function approaches 0, the graph approaches a vertical asymptote. Now when the actual function gets big, the reciprocal gets small. And this is where you have that horizontal asymptote. And then there's some suggestions at the bottom which are key for sketching. Now, let me check if you have to do this on your written response. Yeah, there's a sketch. Yeah, there's 2 sketches. Yeah, so we definitely need to be able to do this. Absolutely, you need to know how to do this. Okay, so what are we going to do first? Find the zeros. That's the first thing. This gives us our what? Vertical. Then mark the invariant. This is how we know where to start drawing. This is where we start drawing. So start sketch here. Start sketching from the invariants, okay? The y-intercept of the reciprocal graph is the reciprocal of the y-intercept on the original graph. Okay, so number 3 there, it just gives us another point. Gives another point. What was that? Oh my god. Having issues here. Dude, I'm losing my mind here. There's a random O there. Okay, so number 3 there, the y-intercept. All it does is this gives you another point that you can use. And then points where y equals 2, whatever. Complete the reciprocal graph on the information above. So basically 1, 2, and 3 here. Okay, you guys ready for this? It's already 1 o'clock. We haven't even done class example 1 yet. Okay, so notice these horizontal lines. Why are those sketched in there? Oh, they already did that for us. Why did they sketch these in? Okay, good. So, invariant. That's where you start sketching from. So, we can mark those in with green. That is clearly red. Eraser. Okay. Oh my gosh. Okay, green. And green. Are there any invariant points from -1? No. Okay. So this was step 2 in the steps. What was step 1? 0. So where's this function 0? Mark that with red. You say 3 at 2. So what can we do at 2? And use your ruler or your ID card or something. What can we do at 2? Yeah. Vertical asymptote. Oh, I hate this stupid smartboard. You don't like red? Okay, so now we got in our asymptote. Okay, so vertical asymptote at x equals 2. Because that was where y was 0. All right, can we sketch yet? We could, right? Does it have to be perfect? But you have to be smart. So let me use my mouse to get you started. So on the previous page, it kept talking about these intervals. Where does it say that? Right here. So if the function increases over an interval, the reciprocal should decrease over that same interval. So let's take a look at this interval here between 1 and 2. What's happening in this interval? The original function is decreasing here. So what should the reciprocal do? Increase. And you can always start at the invariant because you know that point's on the graph. So watch this. Should I use a different color than black? Let's use blue. So why was that okay? Oh, son of a gun. What kind of blue is that? Okay, so there's the start of my reciprocal graph. That section that I drew is from this section in here. All right. Now, what's happening to the left of this invariant point? What's the original thing? What's the original graph doing left of this invariant point? It's getting big, right? So R should get. So should I do this? It's just a smooth curve, decreasing, approaching 0. And that's all you can do. You can draw to the left of the invariant point. You can draw to the right of the invariant point. That's all you can do. Now let's go over here on this other invariant point. What's happening between x2 and x3? The original is increasing. So r should decrease. But this is weird. So when I talk about increase and decrease, I mean what's happening as x goes to the right. As x goes to the right, if your graph goes up, you increase. If it goes down, you decrease as x goes to the right. So from x2 to 3, it's increasing. So we should be decreasing. So the only thing you could do is draw this way. So what happens when you're at 0? What's the reciprocal of 0? And then in calculus, you learn this later, that the reciprocal of 0 is actually infinity. You'll learn that it's basically the same thing as you approach. Okay, so again, with my mouse cursor, back to that intersection we just did. As we approach 0, what is the purple graph doing? Everybody, eyes on the screen. The black graph towards 0, what's the purple graph doing? Increasing towards infinity. Now as we cross over this like parallel universe on the other side, where were you just? Infinity. So now you're going to have to start up here and come down through the invariant point out like this. So this is kind of some weird stuff at first. So symmetric, symmetric, invariant point. Now what's happening on this next section? You're still the black line. What's the black graph doing to the right of the green dot? It's going up to the right towards infinity, so this goes down to the right towards 0. Hard, right? Or easy? Weird. Okay. Okay, so the only thing that I screwed up is if this y-intercept is 3, the reciprocal should be 1/3. So that purple graph should have actually went down through here. So that's the only thing I screwed up. And then it wants us to give, if they give you the original, they want you to flip it. So if the original is 3/4 x minus 2 squared, how would that flip? How would you flip this? 3/4 would become 4/3, and the x minus 2 squared on top would be x minus 2 squared on the bottom. And then you could pump that into the graphing calculator to double check. Okay, let's do this one. Okay, number 1. What's the zeros of this guy? X negative 2, x 1. Put a dot on the zeros. Now what do I do? What do I draw, you guys? A line? Up and down, or left and right? Up, down? Okay. What are these called again? Vertical asymptotes. And what does MC Hammer say about those? Can't touch those. Okay. Now I'm going to draw in the second thing. What's the second thing on the steps say to do? Invariant points. So I'm going to draw in lines at y1 and y negative 1, because these are the ones that don't change. So I got to find those intersections, and I'll use green like I've been doing. So where does those lines cross the actual graph? Here and here, and here and here. So that's where I can start drawing. And let's just use the y-intercept. We forgot to do that on the last page. So where's the y-intercept? Well, it's close to 2, right? So what's close to reciprocating 2? So let's just say it's like 1.8. Reciprocal of 1.8. About half. So let's just find about half. Roughly half right here. So you're going to go through this point from this. Okay, so those are there. Now we get ready to draw. Start at the invariant points. Let's start on the far left. Let's start here. What should I do? Should I go towards the x-axis, towards the red line? Towards the red line, what do you know is going to happen? So let's start at the far left, invariant point on my mouse. So what happens as this goes left? This goes down going left, so it's got to go up. Sketch that in. Now to the right of that invariant point, but stopping at the red line, the graph is going towards 0. So our blue line should go towards infinity. The variant lines come from this, where the original graph is 1 and negative 1, because they won't change. The reciprocal of 1 is 1. So those points are on both. Okay, now in the middle of the two red lines, start on the first invariant point. What's happening here? Towards 0 and the red line, so we should go towards infinity. Oh, I screwed up. Shouldn't get farther away from it. Okay. Now, do you expect some symmetry? So we won't go there. We won't go there. Let's just work our way left to right. Okay, so we just did this little piece down towards the red. So we went up towards the red. Now, for this little hump here, see how these are going up? So, like, what's the reciprocal of 2? Half. So we should be going down through here. And we got to go through that green dot, because that was the reciprocal of the y-intercept. And then we got to go back up towards this green dot. So check this out. As we increase towards that green dot, we should be decreasing towards that green dot, and it should be symmetric. Now once we've hit that, it's actually the vertex. The vertex is where it happens. So after the vertex, you're now decreasing towards these two green dots. So after the vertex, we should be increasing. And then it should just, oh, why did it go to black? Oh, symmetry is so hard. It's hard on the whiteboard or the smartboard. It should just be like a U-shaped symmetric. Okay, good enough. Good enough. Now let's work our way to the right of the right line, the red line. So now we're over here. So what happens as you go down towards this? No, is that what we do? We start at the green dot. Start at the green dot. As the black goes left towards 0, we go left towards infinity. Like this. Now back to my mouse. It is a mirror, good, yep. Of this blue part, yep. So as this black line goes down to the right, this one should go up to the right. But you have to stop at the horizontal asymptote. So the horizontal asymptote at y equals 0. Vertical asymptotes at x equals -2 and x equals 1. Okay, so you're going to have to be able to, for the test, you're going to have to be able to sketch 1 over f at x when f at x is linear and when f at x is quadratic. Horizontal asymptote will always be 0. Okay, so you have enough. Please continue to work into east. I hope that you stick around for east. Okay, guys, she brought up an interesting point. I screwed up here. What did I screw up? Anybody else notice it? The 1/2, good. So I thought 1/2 was here, and I dipped below for some reason. So the reciprocal of the reciprocal of 2 should be roughly half, so it should be in here. So the blue graph, so my bad, should cut like this. So it shouldn't have dipped into the, I don't know why I did this. Just so many lines going on, you kind of lose it. So thanks for catching that.